Hey, hello everyone. This is Chen Ming here. I'm here right now in South Australia, trying to connect water samples from a bowl that is 60 meters below ground. So put 60 meter as in perspective, it's roughly the height of 12 level story building, skyscrapers. So what we got here within the bowl, it's a deep meter. So the deep meter is measuring the water level at the moment. So I'm trying to dip it down. So this one has got a metal at the tip. So if I try to dip it down, you will see that it started beeping. So if I now start off slowing down, you see that water level start off beeping, and then I just move out a little bit. It's not beeping, so which means that the tip is just at the water surface. And if you want to see the water level, it's actually 3150 meters below ground. So I'm now trying to just reel it back. So the other thing that we are doing at the same time is to pump water out from there. So the way how it pumps, as you can see, is that it's getting two tubes. One of them is sucking the water out. So the water goes all the way across the tube and then backfill this cell. So within this cell, we've got a few meters here. It measures pH, EC, turbidity, temperature of the groundwater. So because this water is underground with very low oxygen level, so it actually stinks. So it stinks like a rotten egg. So how we pump it out is we use what we call a micro purge pump. So the pump looks like this. So it's connected to a 12-volt battery going here. And here we've got a pressure gauge here to see what is the current pressure within the pump. And this goes to the controller here. So within the controller, we've got a cycle here. So it basically start off releasing air every 5 seconds and start off inhale, which is to rebuild the pressure every 10 seconds. And the pressure here is roughly 170 feet. So just put that into perspective. So 170 divided by 3 is roughly 50 meters of water. So basically, this air is able to lift water 50 meters above ground. So this goes all the way under the PVC tube, which is 60 meters below ground, and try to push the water out into this tube right now. So what we do on a regular basis is that we try to measure the water level to see whether this water level is decreasing as a result of the pumping we are doing. But currently it's not, because you can see we'll have a chart to show you how that during the process the water level is not actually changed, which means the bowl is very conductive. So we've got the chart, so that shows regularly that the water level, which is pretty consistent, the volume of water that we have pumped, the electrical conductivity, so it's roughly it's slightly increasing, but it's roughly 22 microsiemens per centimeter, so it's slightly less saline than seawater. So the redox is very negative, which is a common feature for groundwater. And then the dissolved oxygen is about 3.8. So if this is aerated is roughly 10%. So 3.8 means that the water does not have much oxygen. The EC here is roughly, it's the same number corresponding to the EC here. The pH is slightly acidic. And so the color is pretty clear. As we can see, the water is pretty clear. But it's very smelly. So it smells like rotten egg. And we've got the temperature here as well. So it goes back to the reason why are we doing this. So here we are in the highland, and in that area, so in the direction where I'm pointing to, it's got the river, and the river is fresh water, so good for drinks. But the groundwater underneath this inland is saline, and the water level here is higher than the river. And in that case, the head difference will allow the groundwater to move to the fresh water and eventually make the fresh water saline. And if that's the case, the fresh water, the river, is not able to be used for domestic and agriculture. So you can see there are some orchards far away from here. So that also pumps fresh water from the river. So what we are trying to see is that how saline the groundwater is and what's the water level, so that we could see how much pressure head difference between the river and the highland, so we can estimate the recharge to the river. So that's the progress we've done here. We're about to finish quickly, and also before we finish, you will see that we've got the water samplers here. So we're gonna sample this water and put in the lab for analysis to see the chytins and anions within the sample. So that will tell a bit signature of the sample here. That's all I'm going to tell. Thank you.